Alright, so this is our next question from Q13, the first lot. You can pause the video and give it a try, and then you can resume for the solution, guys. Okay, so the question says, let alpha and beta be two distinct roots of the equation 2x square minus 6x plus k is 0, such that alpha plus beta and alpha beta are the distinct roots of the equation x square plus px plus p is 0. Then the value of 8 times k minus p is. Okay, so little bit time consuming, but it's not difficult. We can easily do it in a few minutes, like 1.5 or 2 minutes. So I would prefer doing it in like the second round. Okay, so let's see how we deal with this. Alpha and beta are the two distinct roots of the equation 2x square minus 6x plus k is 0. So we can say that sum of the roots alpha and beta will be minus the coefficient of x upon the coefficient of x square. So alpha plus beta will be simply equal to 3 in this case. And product of the roots alpha into beta will be c by a. Constant term c here is k, and coefficient of x square here is 8 is equal to 2. Right, so we've got this relation alpha plus beta is 3 and alpha into beta is k by 2. Right, further we can also see that alpha plus beta and alpha beta are the roots of the second quadratic equation x square plus px plus p. So the first root is alpha plus beta, okay, and the second root is alpha beta. That means for the second quadratic equation the roots are 3 and k by 2. Now for the second quadratic equation x square plus px plus p, the sum of the roots would be minus the coefficient of x upon the coefficient of x square, right? So sum of the roots 3 plus k by 2 would be equal to minus p upon 1. Similarly, the product of the roots would simply be equal to c by a. So 3 into k by 2, the product of these two roots is the constant term upon coefficient of x square. Alright, so that's all the equations we have. Now let's solve them. Let's start with solving for k. We know that 3 into k by 2 is p. So from this particular relation, we know that 3 into k by 2 is p, and that p we put in the above equation, the one above it, and we can figure out the value of k. So we'll write 3 plus k by 2 is equal to minus of p we have found as 3k by 2, right? Now if you take minus k by 2 on the right hand side, you will have 3 is equal to minus k by 2 minus 3k by 2. This is minus 4k by 2, isn't it? Or 2 and 4 on the other side. K is basically 6 upon minus 4, or that makes it minus 3 by 2. The same value of k now you can put in the second equation again. You'll get the value of p. So 3 into k is minus 3 by 2 divided by 2. So 1 by 2 again should be equal to p. And thereby we get the value of p as minus 9 by 4. K we have found as minus 3 by 2 and p we have found as minus 9 by 4. We just plug in the values in the given equation to get our answer. And that's our last step. We have found the value of k and the value of p. We plug in these two values in this particular expression. We get 8 times k minus p as required. 8 times k is minus 3 by 2 and minus p is minus of minus 9 by 4. So that kind of makes it 8 into minus 3 by 2. Minus of minus 9 by 4 is plus 9 by 4. And you can multiply above and below by 2 here. So you'll get minus 6 by 4. Minus 6 by 4 plus 9 by 4 is 3 by 4. So the final answer is 8 into 3 by 4. That should make it 6. The correct answer to our question is 6. As I've said, slightly time consuming. It's slightly lengthy, but it's not too difficult to deal with. The answer would be 6.